For questions 62 through 65, solve each system of equations for x and y by the most convenient method. And as we talked about, solving these systems of equations, we have either substitution, elimination, or graphing. And I can tell you right off the bat that graphing is probably not going to be the most convenient method on any of these if we're having to do these by hand without some sort of calculator as an aid. So let's look at number 62. So on 62, I have the first equation that already has x isolated. Whenever you have one of your variables already isolated, there is a single method that should be screaming out to you, and that is, of course, substitution. Why substitution? Because it's going to be incredibly easy to take this y minus 11 and substitute it in for x in the second equation. Now remember, for substitution, whenever you do it, make sure you take this quantity and put it into the other equation. If you stick it back into the same equation, then everything is going to cancel out and you're going to get zeros equal to 0, which is true, but it's not terribly helpful. Okay, so substitution on this one, probably the best way to go. Can you do elimination? Sure you can, but I think the substitution is even easier. Over here on number 63. Now on number 63, we have these things stacked up in standard form. It does have some sort of decimal numbers here. Could you do this one by substitution? Sure you could. And the reason why you can is because not that one of your variables is isolated like in 62, but you can very easily get y by itself right here if you just subtract over the 0.5x. So that'd be pretty easy to do. You'd have y is equal to negative 0.5x is equal to 9? How about plus 9? And then you could substitute that quantity in for this y, and then you'd have your variables, you'd have your equation with just x's. So substitution is actually a-okay. Could you do elimination on this one? Yeah, you can also do elimination. Now remember, as we talked about, whenever you do elimination, you don't necessarily get the numbers up front, the coefficients, to be exactly the same. You want to get them to be the opposite numbers. And usually you choose the smaller ones because then all of your numbers are going to be smaller and easier to work with by hand. Okay, so in that case, I'm probably going to choose the y's to do the elimination and not the x's. If I do the x's to eliminate, I probably will have to multiply both of the equations by something instead of just a single equation by something. Okay, now the other thing is the fact that we have decimals. Since we have decimal numbers, it does complicate it just a little bit, but you could pretty easily get rid of those decimals if you wanted to. If you multiply, say, all of the numbers by 10, you could just move the decimal place over by 1 if you wanted to. That way you'd have no decimal numbers. Maybe that would be easier for you to work. Okay. Alternatively, you could multiply the top equation by just something like a negative 0.2. That's going to make the y's exactly the same, and then you can cancel those things out. Now, another thing that you could do, this is sort of crazy, is that you have to try to think of, okay, so 2 is actually, so this is 2 over 10, which is the same thing as 1/5. If you multiply this bottom equation by negative 5 instead of the top equation by 0.2, watch what happens. So if we multiply this bottom equation by negative 5, then whenever I multiply this 0.2 times negative 5, it's going to make this a negative 1, and then the y's cancel out. Maybe that is the direction that you go instead. So elimination also works on this one. And whenever it comes down to, when I say the most convenient method, some of that is just completely subjective. It's up to you. Now, sometimes, though, it's objective. In other words, like when I look at this, there is no way that I want to graph this thing by hand, so it is definitely not a convenient method. But this one has two candidates. You can do it by either substitution or elimination, and it's not going to be that big of a problem. Let's look at number 64. Now on number 64, again, I have my equations in standard form. And when I'm looking at it, I don't want to graph it as we talked about before. And I also don't want to do elimination. And I made a reference to this in the previous video when we were talking about substitution. So let me actually demonstrate why this is terrible to do by substitution. Let's look at this top equation. If I try to isolate either the x or the y, this is what's going to happen. And when I'm looking at this, I might go, maybe I want to get my x by itself. So I have 6x minus 5y is equal to 9. I'm going to take the 5y's and add them over to the other side. 6x is equal to positive 5y. Why do I keep doing that? Plus 9. And then finally, I have to get rid of the 6. So I'm going to get rid of the 6 by dividing it over to the other side of the equation. And so x is going to be equal to 5, 6y plus 9 over 6. And that 9 over 6 you could, of course, simplify, but this 5, 6 you're not going to be able to. And so here's what you would have to do. You'd have to take this nasty thing and substitute that in the place of x. And that's a nope. I don't want to do that. You can do it, but that's nasty. There's so many places for you to make some kind of mistakes whenever you do this by substitution. So substitution, it should be kind of off your list, which leaves elimination. And now as far as elimination goes, whenever I go to eliminate either the x or the y, you can see that I'm going to have to multiply both equations by something. I have to multiply both equations because 6 is not a multiple of 9, 5 is not a multiple of 7, or vice versa, so I need to get them to match. And the way that I get them to match is basically like pretending they are denominators on fractions and trying to get the least common denominator. Which one would you choose? Would you choose to get rid of the x's, or would you choose to get rid of the y's? I would suggest getting rid of the x's, and the reason why is that they already have a common factor here. But then some people would look at it and go, hey, the 5 and the 7 have no common factors at all. So what I would do is I just multiply the top one by 7 and the bottom one by 5. Okay, if that's the case, you can totally do that. The reason why I would choose the x's is that since they have a common factor, then that means my numbers are going to be smaller and maybe easier to work with. So here, let me clean this up just a little bit. And we're saying that elimination is probably the way to go here. Check. And if you multiply this top one, so think of, again, if I have something like a 6th and a 9th, and I wanted to add or subtract these two fractions, I need to get a common denominator. And the common denominator here is not just the product of these two things. Since they have a common factor of 3, it's going to be a little bit smaller than that. So again, the method here, the go-to method is to take the bigger number. 6 doesn't go into it, so I take the next multiple, which is 18. Does 6 go into 18? And the answer to that question is yes. So if I want this 6 to be an 18, I need to multiply this thing by 3, and this one by 3. If I want the 9 to be an 18, I multiply everything by 2 and by 2. Right, so that shows us exactly what it is that we would have to multiply. I'm going to have to multiply the top one by 3 and the bottom one by 2 in order to get these both to be 18. But remember, the other thing that we said is that we don't want them to be the same exact number. We want them to be opposites. So actually, I'm going to choose this 2 here and multiply it by a negative 2 instead. That way I would have a positive 18 and a negative 18 on the bottom. Right, and again, you can make a case for doing the same thing with the y's and having to multiply a 5 up here, no, a 7 up here and a 5 on the bottom, but that's going to make the other numbers that much bigger because now we're multiplying by 5 and 7 instead of something like a 3 and a 2, okay? All right, and then finally on 65, it looks like it's going to be something very similar to the 64 that's over here. And actually, on this one, you could probably make a case for it being pretty easy to do by substitution as well. Why can you do this one by substitution? Why? The reason why is if you multiply this bottom equation by 2, it gets rid of this coefficient up here. This would turn into a 1. You'd have x that you could very easily isolate, subtract this over to the other side, and you can substitute it into the other equation. So substitution actually works out just fine on this one. Alternatively, you could, let's see, this top equation, if you notice, no, I was about to say everything is divisible by 3, but that 38 messes everything up, so that's not the case. You could, again, multiply this bottom equation by 2, get rid of the fraction if you wanted to. You could also multiply the bottom equation if you wanted to do this by elimination. Instead of multiplying the bottom equation by 2, you could multiply, well, what do you have to multiply a half by to make this thing equal to 6? How about 12? Actually, you do negative 12. So multiplying this by negative 12 would make these x's opposite numbers, and you can cancel these things out. So it also works out. However, we're having to multiply this by a larger number, makes these numbers a little bit bigger, which means it's a little bit more difficult to work. So substitution might be slightly more convenient to work than the elimination method. So that should wrap up some pro tips on how to solve the system of equations on 62 through 65.